In this video, we will be talking about what is happening when many people use a common resource over longer periods of time. Let's have a look at some examples. With the pasture model, it was pretty simple. The more cows in the pasture, the less milk per cow. The detrimental effect of overuse of the pasture is felt immediately. Let's compare this to the fish example now. When fishing, you can catch as many as you like, and it doesn't affect the quality of the fish at that specific moment. However, the detrimental effect is still there, only it happens much later. The more fish you catch, the less fish are left to reproduce. As a result, in the next fishing season, fewer fish are in the lake. When we want to model this type of situations, we need to find a way to introduce time to our models. At first, it seems simple. It is enough to assume that the same game is repeated. For example, in the simple pasture model, we can assume that the cows go to the pasture the next day and the situation is exactly the same as before. However, this is not a realistic scenario. Typically, what happened on the previous day has an effect on the amount of resources available on the next day. On the one hand, resources are used. On the other, some have a natural capacity for regrowth, while others don't. Resources that don't have a natural capacity for regrowth are constantly declining when used. For example, when we mine for coal, cobalt, or oil, there is less and less of it. If there was a coffee machine in our kitchen and nobody ever cleaned it, it would eventually break. It's pretty obvious that the coffee express will not repair itself. Other resources have a natural capacity to regrow on their own. This applies to the examples of grazing cows and the fish population. The grass grows back and the fish have baby fish. When resources reproduce, we need to think of how this happens and what are the interdependencies. How fast does the resource reproduce? What facilitates this process? What is necessary for it to happen? What can hinder it? We call this resource dynamics. Resource dynamics are a critical issue when we model dynamic processes evolving over time. We will talk more about this in the next steps.